Okay, so can you guys see my screen now?
Yes, sir.
Yes, sir.
Okay, so I have already mentioned this one in my announcement, but please, those who haven't submitted their upload video, their 1 minute video regarding with their name, location, and the gadgets that they're using, and then your expectation from this course. So please do it now. So the due date of this one is until May 10. So why until May 10 only? Because this is where I will base the things that I need to do and I need to change or adjust. Okay, especially your expectation. Right. So if you want to add more, then feel free to do so. So as of now, there's only four who have submitted, and then the others, I don't know. So please do them. So just have 1 minute, so you can exceed to 1 minute. So no problem. This the minimum is 1 minute. Okay. All right. So for the home page, so everything is quite the same. We have the welcoming page. We have the course delivery, which is ODL, of course, and then we have the course overview, which is five course learning outcomes. Well, to be honest with you guys, supposedly this is the actual course learning outcomes if you are in school. So what I mean by you are in school, well, you will go to the laboratory, okay, laboratory room, and then you will perform, the basic things that an electrical engineering student will do. But since we are in ODL, so you will not be able to apply this CLO. But maybe we can um, relate maybe a little, maybe 30% of this one. Since when it comes to apparatus, you won't be able to appreciate it if it's just a picture. So instead of having a real apparatus, we're going to have a virtual application. Okay, so instead of having a that certain apparatus, so it's a blank canvas. Wherein I'll show you guys later. Okay, and for the syllabus, so yeah, the subject title of this one is Electrical Circuits Laboratory. So Fundamentals of Electrical Circuit Lab. And this is a 1 unit lab. So the class schedule of this subject is 11:30 a.m. to 3:30 p.m. Okay, so Tuesday, Friday, Tuesday, Friday. Maybe this one is wrong. Let me just check. Is this Tuesday, Friday only? I think this one is Monday, Thursday. Mm, all right, so right here. Okay. This one is Monday, Thursday. So this is just a mistake. So let me edit this one. So this is a Monday, Thursday. Okay. So for 6.5 weeks, again, point 0.5 is for your exam, midterm, and finals, and then 6 weeks is for discussion. But since this is not a lecture, so we will not discuss anything. All of the discussions will be on the lecture. Okay. So again, the start of the class and then the end of the class. So again, just a reminder. So your midterm exam will be on May 25. So yeah, May 24, 25, 26. So that date. Okay. And yeah, here's the course description. So I'll leave the reading part into you guys. And then here is the course learning outcomes. And then the content, I mean the topics that we are going to, have as your laboratory. So of course, we'll start with the color coding of the resistance. And then for your, actually, week 1 and week 2 is quite because one combined, because in week 1 we are going to have the Ohm's law already. So for the week 2, so it's mostly series, and then why is this one repeated? This one is parallel, okay, parallel circuit. So another mistake on that one. So let me edit this one as early as of now. Parallel circuit, and then a combinational or combination circuit. Okay. And for the week 3, so we'll also discuss how to measure power, okay, but no heat and no light, since this is not a, well, we can measure temperature, I guess, but I'm not sure if it's super accurate. But we can measure the power. Okay, electric power, heat energy, but light, maybe no. And then for the week 4, so we're going to talk about series resistive circuit and then parallel resistive circuit. And for the week 5, we're going to apply, this one is not, uh, okay, I have to update this one because there is an additional. Okay, Norton's theorem is not the last topic for the lab. So I think we have reached until delta to y. Okay, so basically, the topics in lectures is the same with the laboratory. It's just that there is an additional, which is the color coding, and then the rest are the same. Okay, so we're going to apply Kirchhoff's law, mesh, superposition, Thevenin's, Norton's, delta to y, uh, maximum. If we can still, yeah, if we can reach up to that part, then better, the maximum power. So yeah, and then here's the ebook that you guys need to check. So these are the commands or hotkeys commands for the LTSpice. So LTSpice is the application that we are going to use in this subject. Okay, and then we also have here the guide, which is another ebook. So which is another guideline on how to use LTSpice. And then of course the basis of evaluation. So you're only going to have laboratories. So let's say that discussions, quizzes, and assignments is this one, which is your laboratory, and then of course you're going to have examinations. So class standings, 50% are your laboratories, and then 50% for your midterm exam. And then 50% for the class standing, which is again laboratories and finals, and 50% for the final exam. And then same computation, so we have to get 1/3 for the midterm score and then 2/3 for the tentative final score. Then I have just updated this one a while ago. So again, the passing score in UC is 60%, okay, and that is equivalent to 75. Okay, so are we clear so far? Were you guys able to follow?
Yes, sir.
All right, so anyway, everything is in here, so you can just check this one out again later on if you need to check something. All right, so again, just a reminder with week 0 course orientation, so please do this one before meeting. All right, so here's the download link. So I hope that you guys have already downloaded the LTSpice. So just click this one, and then it will lead you to a certain website. So just download this one, 46.15 megabytes, so just a small size. Okay, and then install that one, and then once you have already installed it, then you will be able to have this application or this interface. Okay, LTSpice 17. Okay, and again, whatever we have in the ebooks in the syllabus is I have also included here the hotkeys commands and then the LT guide. For the hotkeys commands, this is where you can see the shortcuts. Say, some simple things like R is for resistor, C is for capacitor, L is for inductor, and then the F1, F2, F3. So here are for the schematics, and then for the symbols, for the waveform. That is, so just check this one, okay? So even though I discuss this one right now, so you won't be able to appreciate it unless you yourself experience it. Okay, so you should do it on your own. So what if I try Control A? What if I try letter U, space, etc., etc.? Okay, so just check this one later on. Okay, and for the LT guide, well, this is just a short tutorial or introduction regarding LTSpice and how to start, where to start, what are the things that you need to do. Okay, which we are going to do right now. Okay, so there are a few things that you need to do in here before you'll be able to understand the LTSpice fully. Okay, anyway, just take your time to read this one. So we have here a passive circuit low pass filter. What is the lab one? Where is that one? I've missed that part. And we have here a step-by-step entry and analysis of a simple transistor amplifier. Yeah, this one is quite complicated already since you guys are just starting to learn about simple circuits, series, and parallel. But as time goes by, you'll be able to learn, the things that you need to learn once you have experienced difficult tasks. Okay, this is one good example. So I'd say that this is not really difficult, maybe just to explore the functionalities or the features of the LTSpice. So yeah, that's the reason why they chose those uh, tutorials or activities that you need to do. Okay, so enough with that. So let's now go over with your week one. So under week one, as you guys can see right now in your portal or canvas, you can only see lab number one. But actually, there's two laboratories which I haven't published yet. So yeah, maybe we will do this one next week since we're only going to meet right now, or maybe we can do this one this week. But I will just uh, put the deadline maybe next week. Okay, next week Friday or next week Thursday, so you can have enough time so to finish this one. So yeah, let's just do something like that. Okay, so again, the first thing that you need to check when it comes to uh, every week modules is the module overview. So in here, of course, we have the topic learning outcomes. We have the list of topics that you need to do, and then the lecture presentation, which is supposedly two. So I forgot to include this one, lab number two, Ohm's law. So in here, this is just emitter color code. So there's two lecture presentation actually. And then for the video material, so I have prepared here how to use a, well, this is actually the most essential. You don't just simulate things in a virtual. So you have to do it on your own. That is why I have included here an actual measurement in digital multimeter or multimeter tutorial. Since you guys are not in school right now, so just watch this video and hopefully you will be able to learn how to use a multimeter, or sometimes we call that one VOM. They are really earning a lot of monies from this advertisement. All right, so this is what you guys are going to do for the lab number one, and then this is the actual testing. Okay, so take note that the variation from this one is not the same with this one. I mean, yeah, you could say that this one is 1 kilo ohm, but in reality, it's not exactly 1 kilo ohm. It's maybe 1,100 or maybe less than 1 kilo ohm. Let's say 980, 990. So yeah, you could say that um, call this one manufacturer of, it's a fault of the manufacturer by not having a consistent uh, value of resistor. So yeah, something like that. So this is just a 5-minute video, so just take time to watch this one. And then I have another video here for uh, those who would like to, watch a Tagalog, okay, Tagalog tutorial. So just click that one and that it will lead you to this, again, another advertisement. Anyway, so just check that one. They're having, or they're showing a lot of advertisements. And then we have another link here on how to read a resistor by its color code, which we are going to discuss later on. That's actually your lab number one, resistance measurement by meter and color code. So yeah, this is just a 2-minute video, just a short tutorial on, telling you on how to measure the, or how to not really measure, how to check the value of this resistor just by checking the color code. So we have the first band, second band, third band, and then the fourth band. Mostly the fourth band, the one that's being separated, this is the tolerance. And then the first three bands is the value of the resistor. Okay, so that is just a short knowledge when it comes to knowing how to check a value of the resistor by a color code. And lastly, on how to use the LTSpice. Again, another ads. So, okay, so let's just wait. Oh, saan na yun? Ito ba yun? May back ko yata. Yeah, may back ko. Ano ba yan? Anyway, if you guys are already hungry, you can eat while listening. As long as, we cannot hear you eating and then we can not see you eating. So, syempre, magugutom kami. Di pa kami kumain eh. Okay, so right here, in here, it will also teach you how to download the LTSpice. Just another, a different link, but same application. And what else? So upon installing the LTSpice, and then this the first setup, and then the things that you can do. Okay, so how to set up a basic circuit, have voltage or resistor, and then these how to set up a value for a certain resistor, etc., etc., and then the transition time, how many seconds it will run, and then how to measure voltage, how to measure current, how to measure the power, etc., etc. Okay, so this is a basic uh, tutorial on how to use LTSpice. Okay, so if you want to learn more, then you can go and proceed to the episode 2. Though this one is already AC simulation. So maybe we can also do one, since AC is just a representation of a sine wave, and this is just a single line. So either of those two, it's okay. And yeah, lastly, we have here the resistor color code chart, in which you can see. So yeah, we can start actually with 4 bands, but we have 5 bands. Okay, though this one is not that uh, maybe common in our for the basic works, but yeah, we have 5 bands, and then we even have 6 band color code. Okay, so this one, the more bands, the lesser the value of the resistor. So this one is for uh maybe smartphones already, right? It's ranging from maybe 10 ohms to 276 ohms. You have here, let's say, maybe a larger, about kilo ohms. We even have larger again, which is maybe up to million, okay, or mega ohms. So yeah, again, just watch this one. I mean, just watch. Just read this one. This is just a 2-page PDF. Okay, so this is just a short introduction regarding with the fourth band, fifth band, sixth band, etc., etc. All right. So what else? And then just a link for the for you to be able to download the LTSpice, and then my reference. Okay, so this is where I got most of the information from your lab number ones, actually from all of your laboratories. All about circuits is very, very reliable when it comes to basics of electricals. Okay, so even the basics of electronics devices. So I've also uh, what is this Spark one? Let me just check this one. Okay, so this is just a website wherein you can follow something, some tutorials. So they have the video, some helpful hints, some simulation about branch-end analysis, simulation about AC analysis, about DC sweep, about noise, etc., etc. So they have a lot of tutorials in there. So you can also check this one to learn more about LTSpice. Okay, so yeah, that's it for the overview for the week 1. So were you guys able to follow so far?
Yes, sir.
So am I too fast or just the right speed?
Sakto lang naman, sir.
Okay. So binibilisan ko kasi alam kong gutom na kayo, and then sabi ko sana 30 minutes lang pero magta-12 o'clock na. Anyway, para makapag-lunch na rin tayo, yung mga di pa nakapag-lunch. Baka may mga nakapag-lunch na dyan. So, okay na kayo kahit overtime na. Anyway, so we're almost done. So again, this is where you guys can see the links for the meeting that we're going to have. Okay, so each module or each week has a Zoom link for synchronous class meeting. So meron tayo dito, meron tayo dito, meron tayo dito. Okay? All right, so let's start with the lab number one first. Okay, so for lab number one, so actually you can remove this one. Okay, by meters. Hindi na siya by meter actually. By color coding na lang since hindi nga natin ma-apply ito in actual since wala naman tayong VOM or kung meron man kayong VOM, yeah, you can try it on your home, which is better. So again, experience is the best way to learn. Okay. However, kung wala namang VOM, so since online distance learning naman, so you can just compute or measure the resistance by using color code. Okay, so let's have a short description regarding with this laboratory. So the resistor is a fundamental electronic component by resisting the flow of electrons in a simple and predictable way. So resistor allows the designer to design as easily manipulate currents and voltages, and currents and voltages are what circuits are all about. So before you measure, okay, so the resistance or simply the value of a resistor determines how it will influence the circuit to which it is connected. So from here, you already know that you don't just put the resistors randomly. Okay, so there is a reason why you have to put 1K, why you have to put 10K, why you have to put 100 ohms. Okay, because you're targeting a specific current or a specific voltage. Okay, so you need to know the resistance of your resistor. So we have two ways to do that one. So we can do by VOM or via meter, or you can do the color coding. Okay. Sometimes the approximate value is fine, but sometimes you need precision. Okay? So dito na papasok talaga yung if you are in, actual hands-on project wherein you need to be precise regarding with the size, not size, the value of the resistor. You need to have a VOM, okay, or a meter uh, a meter for you to be able to measure the exact value of that resistor, because even though we have a lot of 1 kilo ohms resistors in here, all of them doesn't have the same value. Some of them are 999, 998, 1005, 1001. Okay, so they are not exactly as what it is saying by its color. Okay, so the value of a resistor is usually indicated on the component itself with either old-fashioned colored bands or printed numerals. Okay, but these are nominal values, meaning that the actual resistance can be a certain percentage higher. So take note, it's either higher or lower than his indicated value. Okay, so like what I've mentioned a while ago, sometimes it's not exactly 1000, sometimes it's just 900, 11. Okay, so worse is, it's just 500 ohms. Okay, just half of it. Like you're confident because you know that this one is 1000 ohms just by looking at its color code, but in reality it's not. So you have to check it from time to time. Okay, so sometimes it's also being degraded as time goes by. So from 900 will become 855 and so on and so forth. Hey, so the second question here is why measure? Okay, so there are two reasons where you may not be able to confidently determine the resistance from the label. So maybe the component is old and label is faded. So that is also one reason why you need to have a VOM, because as time goes by, so of course the color or the label that you have on that resistor might get fade or might get brushed up and gone. Or maybe you don't understand the color code. Anyway, learning how to measure color learning how to measure a resistor is very easy when it comes to color coding. So you can just watch a 3-minute video and then that's it, you'll be able to identify the value of that certain resistor. Second, you may need to know the exact value of a specific resistor. So mostly this is the main reason why you wanted to measure it using a meter. Okay, you want to know the exact value of that resistor. And also you have to know the law, of course. So why do you measure resistance? Of course you have to know what is the maybe your preferred current and then your preferred voltage. So yeah, in relation with the VIR or Ohm's law. So I will not leave I will not read this part anyway, since we have already discussed this one in lecture. Okay, so we have the easy way using a digital multimeter, okay, or VOM or DMM. Okay, so we have a lot of name to call that one. And we also have the not so easy way wherein you have to do it, step by step by looking at its color. Okay, so that the not so easy way is by, where is the keyword? Ah, sorry. Okay, so this is not the not easy way. It's still with the use of DMM, but you're going to measure the voltage first, the current before you will be able to get the R unknown. Okay, so yeah, this is really the not easy way, especially that you need to measure. You're already using the DMM, but you're not using it to measure the exact value of the resistor. Okay, so I leave the reading part to you guys, and then voila. So he was now able to solve for the R unknown. Okay, just by having that one. And then the last one that you guys can do to measure a value of a resistor, this is one just by having a color coding. So we have number 1 to 10, and I've also indicated here the color of that one just in case you are a color blind. So, just to avoid conflict, because sometimes we're having a debate wherein, this is not yellow, this is red. That's not red, that's blue. Huh? Something like that. So, yeah, I just included here that this one is green, the second one is black, the third one is red, and then the last one is gold. So gray, yellow, gold, and then red. And so on and so forth up to 10. So how to answer? Just refer to the picture below. Okay? Or you can watch this video. Okay? So I will leave the uh, part wherein you'll be able to learn how to measure, how to check the value of this one just by, uh, you know, checking the color code. Okay? So I haven't published where you can submit your work since I'm still finalizing it. So instead of uploading the file, your solution, and then the file, I've created a quiz type wherein you're going. Yeah, it's fill in the blank. You're going to put the value of that resistance, the tolerance, etc., etc. Okay, so yeah, that's it already. And then the last one is case study number 1. Okay, so again, we have facts and then questions. So I'll leave the reading part to you guys, and then for the questions, so just read that one and then just share your thoughts in here. This is a 20 points, yeah, 20 points case study or discussion. Okay, so we still have 4 minutes. So what else that we can do? And also, I think we can proceed with this one, lab number 2. Okay, let me check. So we can have a short discussion. Well, this one you guys already know the fundamentals of Ohm's law, so I will not discuss this one anymore. E is voltage, I is current, etc., etc. Okay, so let me go straight with the procedures. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Okay, so from here, just check this one, and then I've included here the step-by-step, instruction on how to come up with this certain uh, schematic, and then where do you measure, okay, for you to be able to get the value of the voltage in voltage output or V out, which is this one, and etc., etc. Okay, so anyway, we'll be having a part 2, so I thought we can finish this one in just part 1. Well, we will have maybe a 15-minute part 2 later on. So for now, yeah, this is 1 to 9 actually, and then the last one, number 10, is a short conclusion on what you have learned from step 1 to step 9. All right. So again, I haven't published this one yet, so I'm still improving or finalizing the things that to make answering this one easier instead of doing it on a blank uh, bond paper or a blank Microsoft Word. So yeah, that's it for now. And then later on, we'll be having a short tutorials or a short introduction regarding with the LTSpice that you guys are going to use for the laboratories. Okay, so we have a total of 8 laboratories, lab number 8. So that is Tavanins. Is it really Tavanins? I don't know if this is the latest. Maybe I haven't put the latest way. Anyway, so let's see what we can reach or what topic we can reach for this laboratory. So goodbye for now, and let's just start the introduction or the tutorials on the part 2. Okay, so do you guys have a question so far before we end the part 1 of our meeting?
None, sir.
None, sir.
All right.
None.
Okay. How about the others? Mr. Lawrence, Mr. Bradley, okay, Miss Sumo, Mr. Zosimo, Miss Kate.
Wala na po, sir.
Answer.
All
None,
right.
sir.
So see you guys on part 2. Okay, so okay, wait. So how many are we? Okay, so 11. So I'm expecting 11 or more later on. Okay. So I'll stop screen sharing now, and then you guys may now go. I'll just create a new link and see you guys in part 2.